before we kind of dive in, it would be great if you could give an overview to the audience of Microba and what you guys do and what your mission is.
Sure. So Microba is, in the most basic sense, a gut health company. But what we really do is we measure the bacteria in the large intestine. This community is called the gut microbiome. And the gut microbiome is being recognised now by scientists and clinicians as an incredibly important part of human health. And it's playing a role in a few disease states that we're very interested in. So Microba is about understanding the gut microbiome, the role it plays in health and disease, and seeing if we can't be a part of diagnosing and intervening in certain disease states, our flagship program being inflammatory bowel disease.
Where do you see, or how do you see machine learning coming into this that could potentially help automate some of what you're doing, pattern recognition potentially? How do you think about that as your offerings continue to evolve?
We're looking at the microbiome, which consists of thousands of different types of bacteria, and we're looking at the disease states that are associated with the gut microbiome and seeing if we can't find signatures across thousands of variables to see if there's a consistent pattern. And that's obviously something that lends itself very well to machine learning and deep neural networks. So our flagship program, where we're actually doing research, is in inflammatory bowel disease. Mm-hmm. And what we do is we can look at the gut microbiome, the bacteria, the functional properties, and predict using a deep neural network with 97% accuracy as to whether or not someone has inflammatory bowel disease. And we're able to differentiate between the different types of disease in that broad umbrella of inflammatory bowel disease. So it's a great application in a medical real-world setting of using deep neural networks.
So when you have 97% accuracy, what does that enable a clinician to do? Like when you have to that level of accuracy, does it allow you to service more people more quickly? Like what's the actual real world outcome for that?
The big problem that gastroenterologists who deal with inflammatory bowel disease commonly facing is the need to do colonoscopies or endoscopies on people, and there's long waiting lists globally. It's an expensive exercise. So if we can play a part in making that patient journey easier, the diagnosis easier for clinicians, it's going to mean more people get diagnosed correctly and more quickly, enabling early treatment. So we want to make sure that we use a very vast microbiome knowledge that we're accumulating to intervene in really problematic disease states. And there's different ways you can intervene. We've talked about diagnostics just now. That's one way to intervene. But we also know the gut microbiome affects the way that drugs are metabolized and how effective they are. There's responders and non-responders. So if we can identify who the responders are, that's a huge benefit to society, because it means a lot of people, A, aren't paying for drugs they don't need or won't work, but they're not being exposed to the side effects of those drugs also. But where it gets even more exciting is not only just identifying the responders and non-responders, but looking at how you can turn a non-responder into a responder by modulating the gut microbiome.